event-based state transition is a lesser known concept, but it's extremely, extremely essential for event store. I'll use a few examples to explain why it's so critical. So say we develop a tracking system for a delivery company that stores current location of a driver. So imagine this is a map, and each of these lines are streets in there. As a delivery truck moves, the system gets updated. And after a series of twists and turns, eventually it reaches its destination. So imagine that this system of yours was, for some reason, extremely well received by many people in the company, including your CEO, many department heads across the world, and everybody started to use it for their own purpose. So it's a good problem to have, but it's also a curse. We'll see later. One day, the head of analytics visited you and was wondering if you'd be able to provide a historical record of the locations. He wants to use it to estimate the total distance per trip so that he can optimize, say, like a gas consumption. Well, this, of course, was not recorded because the system only stores the current location, and the past location is overwritten by the latest one. And so you decide to extend the database so that it stores historical locations that were recorded. We say that this system stores a series of state transitions, okay, which are all the records on how the location has changed over time in the system. So you may have designed tables like this in the past. You may call it history tables, all the logs, something along that kind of line. So storing state transitions is great because they are a lot more expressive than what we had just now, and it's data rich. You can perform a lot of interesting time-based analysis that we'll discuss shortly. But a problem with this particular kind of state transition is that sometimes it's very hard to understand what kind of change actually happened between each transition. So, for example, given these like discrete locations here, right? How did the driver actually reach the destination? So sometimes this might be easy to reduce. So for example, from 1 to 2 here, the driver probably drove like 5 blocks south, right? But sometimes it is impossible to figure this out. Let's say, for example, here, which path did the driver take to get from point 2 to point 3? Sometimes it's impossible to find out if you don't actually record it in the past. And from the data we have, like we can't seem to translate it. But this sort of data, like having understanding of this can be very important. So for example, in order to calculate gas consumption, the path is very important because like a highway and city roads will use different mileage and different amount of gas, and which path you take has a huge difference in overall gas expenditure. On the other hand, if we were to change this and to store the state transition in a form that represents the transition rather than the state, we can get an even richer representation of the trip. And with this, we can easily piece together how the driver actually got to the destination. And notice how more expressive like the model is actually compared to the previous example. So we call this, transitions that are stored this way, event-based state transition, or in short, an event. And we call the previous models state-based. So in comparison with the state-based data models, an event-based model doesn't store the current state. And so in order to actually get the current state, you would have to go through each of the latest, each of the transitions from the start and to calculate the latest location that is in each step until you reach the final destination, okay? This is extra work and shows like some of the drawbacks of event-based models, even though it's more expressive. So storing data in an event-based state transition model happens to bring a lot of good benefits, especially in the complex system space. So intuitively, you can see this if we put the different models side by side. If you're trying to just get the current location, then the state-based model on the left is definitely the simplest and fastest. However, this type of data model stores very little context and it's hard to piece together and how the business evolves over time. So if your goal is to understand the business more, an event-based model on the right will give you a lot more data to work with. Another good way to understand the nature of event versus state-based is to compare with like vectors and scalars inside algebra. So you can express a scalar on a two-dimensional plane with x and y coordinates, like what we have here. But on the other hand, you can also represent it in a series of vectors instead. This is a useful way to understand event-based versus scalar because vector is essentially a change within a dimensional space. A state change in, say, an ordering system is similar, except the dimensions are not just x and y, but other attributes like the status, shipping address, customer name, and products. So using a vector as an analogy is useful because it's also useful because there are some mathematical properties that vectors we can use to explain like how event-based models can use it. So now that we have like a basic intuition on like a difference between state and event-based databases, I want to emphasize a few more things about events. So first of all, events are the basic components to your state, and it's the smallest units of change. Its granularity is really, really low. In fact, it's easy to see that since you can actually form your state from events, but you can't really do it the other way around. Secondly, events should have descriptive names that express how your business has changed. So just like how vectors are changes in the two-dimensional space, we want events to represent changes in your business space. So for example, instead of using event names like order created, order updated, last name saved, these are very, very technical. Try to use names like order requested, orders packed, orders delivered. This is going to help align the data model with the mental model amongst the different team members.